Hello, hello. We are talking about finding unknown values in parallelograms today. So let's get right to it. We're just going to review some of the parallelograms rules. That way we know how to find unknown values in parallelograms. So going to use those rules that we learned in our last lesson to actually solve for unknown values. We can use what we know now, and I know this is the part that you guys love, so let's get right to it. Okay, I'm going to try to find a place to put my video recording. I know you guys like to see my face, those of you who actually watch the videos. So here we go. DEFG is a rectangle. FD is 3x minus 7. So FD, this whole length, is 3x minus 7. EG is 5 plus x. So this whole length right here. Find EG. So this is what we want to find. We want to find this whole length. We know EG is 5 plus x. Diagonals of a parallelogram are congruent, so we know that rule. We know it's a parallelogram because it says it's a rectangle. So since these are diagonals, that means they're congruent or equal. So we know FD is equal to EG, therefore 3x minus 7 equals 5 plus x. And we use that to solve for x. Do some little switcheroos, and we get x equals 6. We plug that back in, 5 plus x to find EG, and we have 5 plus 6, EG equals 11. That's our answer there. I'm sure you already knew how to do that, right? Well, let me give you this one. Here, W, X, Y, Z is a rectangle. I want you to find the measure of Z to P. P is the center point right here. See if you can pause the video and do this. Alright, hopefully you did. And I'm going to just walk us through how we would do it. Just make sure you got it right. There's probably more than one way to do it. Actually, I know there's more than one way to do it. So I'm not saying my way is the way, but I want to make sure that you know a way to do it. Okay? Diagonals of a rectangle bisect each other. So diagonals of a rectangle, they bisect each other. Alright? So we know that WP is equal or congruent to PY. They're congruent because this bisects it, and therefore they're equal. So we say 2x plus 11 is equal to 3x minus 5. Therefore, whenever we put our x's to one side and our numbers to the other and solve for x, we get x equals 16. Sum of the parts equals the whole, therefore WP plus PY equals WY, this whole distance right here. 43 plus 43 equals 86. So this whole distance right here is 86. Diagonals of a parallelogram are congruent. So not only do they bisect each other, but they're also congruent. So WY equals XZ. They are congruent, therefore they're equal, so XZ equals 86. Diagonals of a rectangle, they also bisect each other. So again, just the same thing that we did here. So ZP is going to be congruent to XP. So we would say, or we could say ZP is 1/2 of this whole because it's bisected. So half of 86 is 43. We have our answer. See, this is easy stuff. I knew you guys would get it pretty quickly. Alright, ABCD is a rhombus. Find CD. So we want to find this measure right here, CD. Okay? See if you can figure that one out without my help. Alright, maybe you did, maybe you didn't. Let's look here. Sides of a rhombus are congruent, so we know AB is equal to BC. AB is equal to BC. So we know 2x plus 3 equals x plus 7. You say, why didn't you just tell us, this one right here, if all of them are equal or congruent? Well, we don't have anything to go off of here. It doesn't tell us this measure, so we can't find CD without knowing what x is first. Okay? So we find x equals 4. We plug it back in. We say 2 times 4 plus 3 equals 11. AB and CD are equal or congruent or equal. And that means CD is 11. All right, give you another rhombus here. ABCD is a rhombus. We want to find AC. Find this whole measure right here, AC. Can you do it? Pause and see if you can. All right, P is the center point here between these two diagonals. Remember, rhombus, really every parallelogram, diagonals, they bisect each other. So that tells us pretty easily AP and PC are congruent, therefore equal. So we set up this equation and we get our answer x equals 5. So now we know that AP plus PC equals AC, sum of the parts equals the whole. So we put these in, we substitute our 5 for x to get our answer for AC. 15 minus 1 plus 5 plus 9 equals AC. AC equals 28. Okay, so AC equals 28. All right. Now we've got another rhombus question here. ABCD is a rhombus. The measure of angle BCD, so this right here, BCD, this big angle right here is 54. We want to find the measure of angle BAC. So we've got this big angle right here. We know that's 54. And this, we want to find the measure for. Okay? I've given you a hint already, but go ahead and see if you can solve the rest of this right here. All right, hopefully you paused it and were able to solve it. I'm going to walk us through it right now. Opposite angles are congruent in parallelograms. So we know that this angle, angle C and angle A are going to be congruent, or DAB is congruent to BCD, just to clarify. Also, in a rhombus, diagonals bisect opposite angles. These diagonals bisect the angle. So here we know that the diagonals bisect opposite angles, so that will tell us that the measure of angle BCD, or 1/2 of that, is 27. So we know that, this angle right here, BCA and DCA, are both 27 degrees. So we know that. All right, and 1/2 of measure of DAB is going to be 27. So we know that those are congruent or equal. 1/2 of DAB, 1/2 of DAB is BAC or DAC. So 1/2 is true of either of those sides, and therefore we know that the measure of angle BAC is 27 as well. We could have inferred that from this right here, knowing that in a rhombus, diagonals bisect opposite angles, so we could have inferred that from this point, but I just wanted to show how that can be true. Okay, last one, I promise. Talking about a square. ABCD is a square. AP is 3. What we want to find is BD. So we want to find BD, this whole diagonal right here. See if you can do that. All right, hopefully you paused and you did that. I'm going to walk us through it right now. So diagonals of a square are congruent and bisect each other. So they are congruent and bisect each other because it's a square. AC, that means this whole distance right here, is double the distance of AP because this is bisected, so it's just that times 2. So it will be AC is also congruent to BD. So AC being twice the distance of AP is 6. So therefore BD is 6. Okay. We got one last one here. ABCD is a square. AP is 3. Find AD. So how are we going to find AD? Diagonals of a square congruent and bisect each other at right angles. Therefore APD is a right triangle. Triangle APD is a right triangle. And DP is going to be 3 because that means it's an isosceles right triangle. Okay, because we know that this is 3. They bisect each other and they are congruent. So we can use a Pythagorean theorem. We know AP squared plus DP squared is going to equal AD squared. So 3 squared plus 3 squared equals our missing distance. 9 plus 9 equals 18. 18 equals AD squared, or C squared, what we're looking for, the square root of 18. is AD. We square root both sides, and that cancels out. So we're left with AD equals the square root of 18, which is somewhere like 4.1 or 2. Okay, so that's right where we're at for AD. 4.24. I had it written down already. Look at how smart I am. Okay, so this is just some questions, some sample questions. These will be some of the questions you'll see on your quiz and your test. And if you have any questions, you just let me know. All right.